actually have got something which is actually called the second shifting theorem. So today we are going to look into the second shifting theorem. Okay. So let's check second shifting theorem. So today also we're going to do few sums. We have to understand how does this second shifting theorem works. Okay. And this is also for Laplace transform, not for the inverse transform. So what you do is, in general, when we take it, Laplace transform of f of t, okay, we simply write it down as f of s. That's our Laplace transform. And what happens in the second shifting theorem is this: take form of t minus a, and then can have another function h, which is again a function of t minus a. This is actually given as e to the power minus as f of s. So this is the second shifting theorem. Don't worry, we're going to do problems so that we understand that what exactly it means and how we actually use it. E to the power minus as fs. Okay, so that's your second shifting theorem. Before we do, we need to know what is our h. So ht minus a is actually nothing but a step function. Okay, so you have a graph. Okay, and then let's say you go from here to here, and then you go from here to here. So this is basically a step function kind of structure, right? So this h is nothing but a step function. So I just write down here. This is unit step function. Okay. And here what happens is we have got h of t minus a is equal to 1 if this t is greater than equal to a, okay, and is equal to 0 if t is less than a. That's the definition of step function. Okay, so this is the step function that we have here. Okay, so this is the second shifting theorem. So depending on the question, you can get any of these questions. Okay, so let's just do an example. Once we do an example, I think it will be more easy. So let's take one simple example here. And let's say we have got the function as this. Okay, it will be f of t. Let's say sine of t minus of pi by 3. I think you can judge now that pi by 3 is actually a here, and this is 0, and this will be valid. Okay, for t pi by 3. Okay, so maybe I can just write down this. Sorry, greater and less than. Okay, let's keep it this way. What you can do now is we can do slight modification here. We can actually take this sine of t minus pi by 3 separately. Then for both of them, I can do it this way. This will be 1. Okay, and then for t greater than pi by 3, and this will be 0. This into 0 will remain 0, and this into 1 will give this term. This is t less than pi by 3. So you see, this particular part is actually a step function. So you are basically having a product of two functions here. One is sine of t minus pi by 3, and other one is the step function that we have. Okay, and this is the beauty of doing this. That means this particular expression or this particular site, this part actually can be written as h of t minus pi by 3. That's the step function that we have. Plot a graph, you'll get it in the form of the step. So that's why it's a step function. So that means simply what I can do is I can just simply write down as sine of t minus pi by 3 into h t minus pi by 3. Okay, so if we take it this way, we are going to get the expression. So this is the one for which you can actually use the second shifting theorem and find out your result very easily. Okay, so let's see how we can actually do it. Okay? Let's try doing this. So this is t minus pi by 3. So first of all, let's say I need to know what is the Laplace transform of sine. So let's say Laplace transform of sine of t. Sine of t is equal to 1 divided by s square plus 1. Okay, this is 1 divided by s square plus 1. Okay, so 1 divided by s square plus 1. And we can actually now take the Laplace transform. We need the Laplace transform of this entire term. Let's see this. So we'll take the Laplace transform of, f of t minus a, and then h of t minus a. A is equal to L, and let's write down our functions now. The function is sine of t minus pi by 3. I'm doing it slow because this is the first one we're doing on inverse, the second shifting theorem, and this is h of t minus a. My a is again pi by 3. You have to just do it step by step. Okay, we have it now, and then let's just do it now. So this is sine t of t minus pi by 3. Okay, so if you just do your calculations here, you can actually get your results easily. So see this, e to the power minus as into fs, e to the power minus as, and this particular case our a is equal to pi by 3. So that means the result I need to write down is nothing but e to the power minus of pi by 3 into s into fs. So fs is nothing but f of t minus a. Okay, so this is nothing but the transform of sine, 1 divided by s square plus 1. Okay, fs. That is what f Laplace transform of f of t. This is Laplace transform of f of t. That means without the a, so it is 1 divided by s square plus 1. If it was having a coefficient of 3 or something, it will be square plus 3 square, whatever. And then we just take this, we are going to get this into f of s. Please remember, f of s is this, not the Laplace transform of t minus a, the Laplace transform of t. And this is the one. And this is actually your second shifting. Okay, so can we just do it even without using the second shifting theorem? The answer is yes. So just do your integration here using the Laplace transform, e to the power minus st sine of t minus pi by 3 dt. Do your integration, you should be able to reach here. But then this is only just a 2 or 3 line answer that you can do it very easily. Okay, should not be very difficult. Okay, let me take one more problem, and if you understood your second shifting theorem, you should be able to do it. Okay, so this is e to the power t minus a. That's the function. Okay, and then this is 0, and this is t greater than a and t less than a. This is your task. Do it now. Do this because I think this is one of the simpler ones. You can use it. Okay, so that you don't get confused. T is equal to f of s, and then if you want to use the second shifting theorem, this will be f of t minus a, h of t minus a is equal to e to the power minus as f of s. That is equal to 1 divided by s minus a, and here it's t minus a. Okay, and the Laplace transform of ft, that means that function is nothing but e to the power t. E to the power t, a is 1 here, so it will be s plus 1, right? So Laplace transform of e to the power 1t is 1 divided by s plus 1. So this should be your answer. Okay, I'm not solving it. You have to solve it. If you have not done it, you difficult. You have to practice it. If I solve everything, it will be more of a spoon feeding. I don't want. Let me give you one more example. Let's one more. So it seems around 3 or 4 of you got this. One should get it. Let's see how many of you can do the next example. The next example is, this could be the answer. Okay, that's it. Cos of t minus of 2 pi by 3 and 0. And then I think you can guess t is greater than 2 pi by 3. So in a way, you can easily know what is your A if you know what is the boundary conditions that are being provided. 2 pi by 3, and this is less than 2 pi by 3. Okay? That's the boundary condition. You can do it quickly and tell me what's the answer for this now. Okay? So do this. Okay, should do it together. So last topic for the second unit is the second shifting theorem for inverse Laplace transform. Okay. Second shifting theorem for inverse Laplace transform. So we have to take the inverse function. Can you just turn your mic and mic is on? L inverse Fs is equal to f of t. So this is the inverse transform. We already know. This is S, this side is t. Okay. We're just going to take the second shifting theorem and see how it is used in the inverse. So in the inverse, in the Laplace transform, you have f of t minus a, h of t minus a. So in the inverse, and the result is e to the power minus as fs. In the inverse, it will be e to the power minus as fs is equal to f of t minus a, h of t minus a. That's really transform. Okay, very simple. And we can actually take a look. So every function, if it's given and if you are asked to find out the inverse transform, you check whether that Laplace transform that has been provided is in the standard form or not. Okay, it's not that every question will actually have an answer. So inverse, and this is e to the power minus of pi by 3s into 1 divided by s square plus 1. So as soon as you see that it is 1 divided by s square plus 1, means we are talking about a sine function and not a cos function. Okay, so these things, yeah. So these things you have to do it mentally, so that finally when you arrive at the answer, you don't arrive at the wrong answer. Very important. If there was an s here, we're actually talking about a cos function. Okay, so please make sure that these things you are very comfortable with. Okay, so I'll just check that first. So I'll just write down the sine function. So I'll just write it down as L inverse of 1 divided by s square plus 1 is equal to sine of t. I've sorted that out, and then I can just find out what is my inverse. So inverse, I can just take e to the power minus of pi by 3s into 1 divided by s square plus 1 is equal to sine of t minus a.
Pi by
Yes, correct. H of t minus a. Right. So that means I can just simply write it down as sine of t minus. Now a is pi by 3, so I'll just take pi by 3. And then I'll just take h of t minus pi by 3. In Laplace transform, we are getting this equation, right? We're going to get this equation in Laplace transform. In the inverse, we are just going to write down whatever we started in Laplace transform. Okay, so that's how we just do these steps. Okay, and then this is very simple. Okay. Okay. So what you can do is you can just simply write it down as sine of t minus pi by 3, and then this h a step function by definition. So that means it will be either 1 or 0. It will be 1 for t greater than pi by 3 and will be 0 for t less than pi by 3. That's it. That's your step function. Okay. But then when you write down the final answer, we don't write it down in this. We write it down here like this. You don't put that curly bracket, then also it's fine. I'm just giving it so that things are clear. You need to give the curly bracket. Pi by 3, and then this is 0. This will be t greater than pi by 3, and this will be t less than pi. So you arrive at here. So when you do the Laplace transform, you start from here. Okay, you arrive here. When you do inverse transform, you start from here and you arrive here. That's it. Okay, that's the only difference that you usually do. Okay, one more problem. Maybe you can do it very simple. Okay, I take my favorite E function. So see, just by looking into the problem that we're solving, you know there can be numerous problems. Okay, I can take any book, maybe the book that you follow. If I take that book also, you'll get so many questions which are probably unsolved, or probably you did not pay much attention and I have paid attention to it and I have put that question for your exam, and then you think that okay, this is not done in the past. So mathematical physics doesn't work that way, just like maths, right? So you have to know the procedure. If you know the procedure, you can try an exam and probably get your answer. That's very important. Okay, try doing this. Tell me fast. What's the answer?
So e for t minus a
You can really get
t
it,
greater
right?
than a.
Because you know this is actually in the standard form itself. This is a, that means your t greater than a, t less than a. 1 divided by s minus 1 means to the power t minus a. So this is the speed that is important, which is needed. If you do it, you'll see that this is to the power t minus a for t greater than a and is 0 for t less than a.
0 t less than.
Sorry, a. So why you are able to do it so fast? Because you know the results of Laplace transform, and that is why it's important. Just like you remember ddt of t to the power is nt to the power minus 1. Just like you remember integration of sin x is nothing but cos x. In that way, whenever you are going to use these results in Laplace transform, these results are going to come out very fast. And most of the time it is expected that you are able to do it in this method. Okay, this is the short method, and this is very important for entrance exam. As far as your exams for these questions are concerned for your NSEM, there I'll clearly mention that use the second shifting theorem or the first shifting theorem, or you look into the marks and you'll see that okay, I've given you 5 marks. Let's say I've given you 5 marks. And I have told you to find out the inverse transform of this. Now you have to judge what you need to do. If you use second shifting theorem and you're going to use it only 2 lines, you're going to find out the answer. Probably there is no justice to the marks. Okay. So just to avoid that confusion, I will just try to take extra care. Or if I have not written that, and ask me in exam during exam time also on the question. So I'll take extra care to write down, mention there that don't use any shifting theorem.